Hello, my name is James Black, and today I'll be going through a comedy of errors while designing a reactive application. So, a client wanted me to make a secure messaging app for a mobile device. I decided to take the easy way, and so I had a server that had Windows Server OS on it. I put it on a web server, in this case it was Tomcat, and a database, which was MySQL. And I told him that it'll be down about 3 hours a month due to Windows patches, but we could probably schedule that during reasonable times. My goal was to have 98% uptime, which is down 14 hours a month. This was 99.5%. He wasn't real happy about that, so I decided to make a change. I put Linux on it instead of Windows, so it'll be down 1 hour every 2 months. 99.9% uptime. Then we were doing some pilot testing and the hard drive failed. We were down for a day. Since we had to move all the data, reconfigure everything, the client was not happy. So much for my uptime. So after looking at different options, we decided to move to the cloud. Using AMI for the web server and the database, down 4 minutes a day, 99.99% uptime. So now things are looking pretty good. Now we're going to start doing some more beta testing with 10,000 users. We find out fairly quickly that there are too many client connections to the web server. So I think about it and I realize, we really need to have multiple web servers so that way they don't have these kind of problems. So I just use auto scaling. Nice and easy with AWS. Then we continue to test, and then we start getting errors, and it's too many connections to a database. So then I think about the fact that, okay, I have all these web servers, they're all connecting to one database. The database must be getting overwhelmed. So I start to think about, well, how can I improve the database? I don't want to have multiple databases because I have to deal with replication myself, and I've done that before. That's a big pain. So I look at Brewer's theorem. Brewer's theorem says that you can have a choice between consistency, where all nodes are always in sync, the replication issue. You can have partition tolerance, which is you can be on multiple partitions or multiple nodes, which is what we're looking for. Or availability. You want to always be available for people. So you get to pick two. So after thinking about it, I decided that I'd rather have availability and partition tolerance, AP. So I decided to go with a distributed database that supported that. In this case, the Aurora database. And so this is what my architecture looks like. So every web server can talk to every database node. So that's my final infrastructure. In actuality, I don't see all the nodes. It's abstracted out for me. I just connect to a database. Amazon takes care of which node I go to. So the application is very popular in spurts. Demand ramps up from 100 requests per second to 1 million requests per second over a 5-minute burst. So some clients are getting errors. The problem is that auto-scaling can only scale so fast. So generally you have a 5-minute cooling off period to see how everything goes before you look at creating a new VM. And it takes time for these Amazon machine images to start up. Take 2 to 3 minutes. So there's this built-in delay just because of that. So I could see about using an ESB. An ESB would help, an enterprise service bus, because then I would just put everything into a pipeline, and then I could just go through, make all the calls I need to the various web services, to the database, come back. It's kind of built for dealing with lots of traffic. But every call, every branch off is slow. You end up increasing your latency by quite a bit. And in my experience, an ESB is going to slow down the user experience a lot. That's bad. So I could go to just having lots of web services, because right now I have one web service. I have all of my web services on the same web server. So you call, and depending on what parameters you pass to the URL, you get any of several web services. So I could split them all up and just have multiple. So in this case, I could actually have 4 different web servers that are hyper specialized. So before, where I was showing the 3 web servers, I could just have that be 12. And that could be a reasonable approach. But that would still run the same kind of problem, because if everything is hitting the same, like message web services, then I could still be back to where I am now. That doesn't solve my problem. So I decided to go to Docker. On Linux, Docker containers can come up within 50 milliseconds. I've seen numbers where it can come up within 17 to 20 milliseconds. So what I can do here is, for every connection, I could just bring up a web server for that connection. And that seems like the most reasonable approach. So that's what I decided to go with. So that way, I'll end up having lots of web servers up, but they take up very little memory. It's a nice, quick way to do this. But then I started seeing that I have various challenges with concurrency and with client server, because in my web services, to try and speed up activities, sometimes I have to have multiple threads spun off to collect all the data I need from the database, so I can then bring it together in my controller, do my logic to determine, for example, did you answer the questions correctly, so you can log in. And so I'm starting to re-examine, does client server make sense everywhere for me? So, for example, the issue is, if you look at all of these different calls I have to make just to see, did you answer? I want to generate a token. That's the outcome here. So I need to make sure that you gave valid answers, because I'm actually using, rather than using the regular login, I'm actually using the zero knowledge proof authentication. So I don't actually know your password. I know a hashed password that you had generated, and then I ask questions based off of that. Then you answer them, and then I look, and if they match, I give you a token. So even if someone tried to take my database, I can't recover the passwords. I never see a password. So I don't know if I don't know much about what's going on. So this is a security concern of mine. So the problem is that I retrieve the user and I retrieve the password happens at the same time. So when you start having a lot of activities happening at the same time, you have to make sure that you don't go ahead. You can get into race conditions, you get into various paperwork handling in the software just to make sure that everything works properly. And it gets to be hard there's room for error there. So then I start to think about, a long time ago I used to do some Erlang programming. And Erlang, rather than using the client-server approach, they go with passing messages everywhere. This is an old concept, Smalltalk used it. And by passing messages, now I have these little tiny programming units that share no state. All they know is what was passed to them in the message. They do their task, and then they send a message somewhere else. When I send them a message, I'm not necessarily expecting a response back. It's more send and forget. But if these things go down, then a supervisor actor would know about it, and there's various ways that they can handle restarting the problem, restarting the work, or passing an error. There's different options they have on how to handle when actors fail. So I like this approach, but I need to find something like that for Java. So I found Akka. And Akka provides this kind of functionality for Java and Scala. Now, Akka actors work the same way. You pass a message, and you build up a hierarchy. So you don't want to have lots of actors all at the same level. You want to have actors that are very deep, so that way when you catch exceptions, so as I go through, you'll see that this is a flow of how which actors are getting called. And when I get the answer back from the database, it passes the message directly back. Now, if there was a failure in user.dao select user by username, for example, let's say the database is down for some reason, then the DB service user controller, for example, may have been the supervisor and could say, oh, database is down, and then we would already have requirements for how that's to be handled, and it would handle those appropriately. So if there was something that happened because there was a formatting problem, for example, you passed in a string when you're supposed to pass in a number, then that would also, we'd have ways to handle those kind of errors, because that may have crashed the select user by username. But, and then it just continues on. So the login controller get token actor actually is more of a state machine. And so based on this current state, it looks at where it needs to go. And then the final token gets passed back to the controller actor. And this shows more of, for all these different connections, how all the actors are tied together. So what I did by going with this approach is I made my reactive system. A reactive system is defined by four attributes, or four qualities. It should be responsive, resilient, elastic, and message driven. So in this case, I'm just talking about just the server side. In order to make it truly responsive, I'd have to also do some work on the client side, but that would be for a later discussion because that involves different tools than what I'm using here. So, but it is responsive within itself. Ideally, I would split up the web service, so I would have two different web services, one around the database. So all communication with the database is solely the purview of this one web service. And then another web service for my application. So that way I get the reusability of the database if I need it for something else. And I can make that responsive. So that way it can handle things in a timely fashion. If one of the things about actors is if something is taking too long, you can actually have it fail, and you can know this is too slow. I need to respond in a different way. So that way we don't have where people are having to wait minutes for a graph, for example, if it's just the system's overloaded. You also want it, the goal is also to be more resilient. So when bad things will happen, you'll have hard drives fail, you'll have network connections, you'll have bad data in the database, you'll have inconsistent data because our database is not guaranteed to be consistent. It's eventually consistent. So you need to be able to make sure the application doesn't crash, that the user doesn't have to get an error saying the system is down. The goal is to be like what Netflix does. Netflix has what they call chaos monkeys, where they will go in, they will take down an entire AWS region in production and make certain that people don't notice and that everything works fine. They'll make the database slow. They'll just put things in to kind of mess up their production environment to make certain that their system can handle it. That's the goal that we all want. You also want it to be elastic. So I got the elasticity by using Docker and also Akka. Ideally, if you know all of the IP addresses that you're using, you can make Akka clustered. There are ways to do that. And then I create actors, and it can create actors on different machines, and it can use them all. So it doesn't have to be using just the actors on the machine that you called it from. The problem is that in AWS, I don't necessarily know the IP address because it's bringing up these different Docker containers and giving them IP addresses. So I don't see any way yet to build a cluster. I think AWS is going to have to help solve this problem. Or someone outside of Akka there's going to be a solution outside of Akka. But by using Docker, I can make my system very elastic. That's why I went with each request has its own Docker container. And then it's message driven. This is important because by making certain that when you send a message, everything is isolated. So like I said, each of these programming units, these actors, they don't share memory with each other. So there's for example, no static method that they're all going to be working out together on using because they may be on different nodes. So you have to design them to make sure that they are completely self-contained. And by using Docker, by using these different approaches, I've built my reactive application. So then for my deployment process, just to kind of show everything, I decided just to make this automated so I didn't have to keep on doing a lot of work. So I commit the code, and then everything from then on gets automated to where the code is built and tested, the Docker container is created, it gets deployed. I'm using auto-scaling, and I'm going to a database. It's pretty simple. So I started with a simple mobile to server approach. Then I ended up moving to the cloud. But then because of other issues, I had to, while I'm in the cloud, use a distributed database. And then because I wanted to make certain that I could be elastic, I used Docker instead of AMI. And then to get better isolation, because client-server approach doesn't give you the ability to be able to isolate, and I want to be able to pass messages, I went with Akka. This is a very simple application, in actuality. There's probably 8 or not 10 web service calls total. It's simple. If you wanted to have a lot more complex applications where you are having a predictive analytics system, you're doing a lot more data warehousing, you have a lot more connections coming in, a lot more, you're pulling in data from lots of different sources, you can still make it a reactive system. But I have skipped the complexities of trying to deal with multiple applications and make the entire system, similar to what Netflix has done, reactive. And then I skipped discussing other languages, such as Elixir, which is built on Erlang, that would help make this also a better system. Because there is a problem that I encountered, which is there's a paradigm disconnect when my mobile app communicates with the Tomcat server. The Tomcat server then has to translate for and then start using actors. So there is still a client-server interface there, but there are ways to help limit that on the mobile side, but that interface is kind of kludgy. In some ways, it might be better if I used a different web server approach that can use actors right away. But still, this is a very simple way of explaining how a person can build an application, a simple application, to be reactive. Thank you very much.